Welcome to RSET Online. I am Krishna Kumar K P. Today I'll be covering a topic from 5th module SAT Petroleum Engineering. The topic is well logging tools. My contents are organized as follows: introduction, need for well logging, spontaneous potential logging method, acoustic logging method, gamma ray logging method, caliper logging method, and finally reference. Introduction. Various methods are used for well logging. Logging is very important for the mining operations. The main methods that we will cover include spontaneous potential logging. USIT stands for a kind of acoustic logging method that's called ultrasonic imager tool. Then comes gamma ray logging tool, caliper logging tool. In fact, we consider a much simplified version of each, and a more detailed analysis is given in reference. Need for well logging. There are mainly two needs for doing the well logging operation. To check the well casing and cement bond locks. Basically, it is the condition monitoring of the well bore perforations and any kind of drift in the pipeline structure or well bore structures. Second need is again to estimate what amount of crude is left over by indirect measurement of well logs and correlation techniques. We will come to correlation techniques in the coming slides. First we will see spontaneous logging tool. SP tool is construction wise very simple and operation wise also it is very easy. Better suited for well to well correlation analysis, and this has one shortfall, that is it is only applicable for onshore wells, cannot be used for offshore or subsea wells. Okay, principle. Potential difference between the surface electrode and movable electrode is measured continuously as the tool moves deeper down into the well. The potential is recorded for analysis. I'll show you in the next slide. Okay, this is the familiar formation recalled from your previous classes. I have skipped many other layers to make the diagram as simple as possible. So this portion represents the surface electrode. Okay. And wire is drawn to the movable electrode which passes through the pipeline of the bore, and it is connected to an electrical source as well as a measuring device. I have shown only the measuring device here, but it should be driven by a generator or a battery as well. So when this mechanism moves downwards, this keep on reading the potential activities, so it can go deeper into the well and measure the electrical potential. Now a typical log of SP method looks like this. This is figure is taken from PetroWiki. Initially for a particular layer of rock the potential will remain same. As soon as the layer changes, you can see there is a rise in the potential, and intermediate layers will be the shale and sandstone. That time there can be a dip also, and gradually when you take the average it keeps on increasing. This is called baseline shift. You can see as the tool goes deeper there is a shift in the baseline. So that is nothing but when you look into this figure, you can see as this move more deeper in, the more resistive path it has to overcome. So naturally the potential here increases. It is by the simple Ohm's law. Now next portion to be covered is acoustic logging. Principle: by measuring time of flight. You can have one transmitter and one receiver, ultrasonic transmitter. It's made of piezoelectric material excited by some oscillators. So when this transmitter is excited, it keeps on sending waves and the waves will get reflected at the bottom of this block, and the receiver receives the waveform after a time t, capital T. Okay. Now, when there is no damage or holes present in this cast iron block, uh, you can observe this waveform in the CRO, both transmitted and received waveform in the cathode ray oscilloscope or digital storage oscilloscope after a time period T. Now suppose imagine that there is a hollow block, there is a hole present in the block. Okay, so some part of the wave marked as red lines will get reflected prior to the main wave. Okay, that is marked as row 1 here, and with the small spikes. So by looking into this waveform patterns, one can guess whether the block has a hole or not. The measurement principle is very simple. It's called time of flight measurement, and ultrasonic logging tool contains one transmitter and a receiver, and even multiple configuration is also possible. So transmitter sends waves into the rocky layers as well as the well casing or the pipe well bore. Okay, sends, and the waves after passing through the different layers will get reflected back into the tool's receiver. Okay, now typically the waveform will look like this. This is the transmitted waveform. This first arrival corresponds to the pipe well casing mechanisms. Okay, well casing or the metallic structures for the well casing. Now you can see the second arrival that corresponds to the immediate rocky layers that is in contact with the well bore. Okay, now late arrivals are there that corresponds to the structure far from the well bore and composition, and it can also correspond to the porosity parameters like porosity, the sedimentation. Okay, now as layers changes also, you can see there will be a drift in the late arrival mechanism. Now imagine that the pipe has some fault here, this location. That time you will observe a small peak that corresponds to the fault. Okay, so the first arrival is some others refers it as P1 wave, second as P2. So this waveform corresponds generally. If one looks into the waveform, you can see you will get to know idea about the bore structures as well as the what amount of material is left over in the or petroleum crude or gas is left over in the oil well formation. Okay, now we will see gamma ray logging tool. The transmitter is made from radioactive sources like uranium, thorium, and isotopes of potassium. Detectors are Ziegler-Muller counters. The rays are not reflected here, should be kept in mind, but scattered. The scattering will be Rayleigh and Compton's scattering, but scattered in and around the formation where logging is done. Okay, now gamma ray typical units for gamma ray in petroleum engineering world. APA has created GR units, some in the range of 0 to 100. This figure is taken from reference. Here you can see again the variation in gamma ray reading as the well moves deeper. The tool moves deeper into the well. Okay. Now last logging method is caliper logging. Caliper is a simple tool. It has multi fingers of linkages connected. So when this tool moves below, it can find any fault or any bend for the bore well or the piping structures. Damage can be analyzed simply by measuring the movement of this caliper. Okay, so caliper works on mechanical movement principle. It can if any drift occurs to the structures, it can create a bend in the well casing. So that can be measured very easily using a caliper logging tool. In fact, for a petroleum mining operation, we have to use the combination of all tools for measuring the performance of well. Okay. Now conclusion. the advantages of well logging tools: easy to acquire the signal, better resolution than seismic data, economical, limitations in direct measurements. So you need to get a lot of logs or recorded data to get into a conclusion whether any petroleum is left over or any amount of material is getting contaminated, etc. Then it is limitation. There is also limitation by the tool. See, as I told you, caliper tool can only measure the drift in the pipeline structures, whereas gamma ray tools can measure the amount of material like that it goes, and it is sometimes affected by the environment also. Now coming to the reference, you can log on to this website, Dr. Paul Glover, Petrophysics MSc course notes, www.homepages.c.leeds.ac.uk. So we'll see in next another location. Thank you.